Human attention helps us navigate our surroundings and determine what is of importance in that moment. Attention itself can be defined as the enhancement in our sensory processing that is focused on one area of our visual field. Our attention is not pulled randomly or sporadically. In fact, there is a fairly well understood basis for what features or events call our attention. In general, we might consider two major modes of attention: top-down processing and bottom-up processing. Top-down processing is considered more goal-directed in that our current situation may control the way that we give something our attention. For example, the following image demonstrates how our brain will often consider what it's expecting. In this way, top-down processing might be thought of as context-specific processing of information. Bottom-up processing, on the other hand, speaks to the way that our brains are called to stimuli in the environment. One event that causes bottom-up processing is motion. For example, this object on its own may catch our attention simply because it moves. In this way, bottom-up processing may be thought of as stimulus-driven processing. These definitions and examples act as a very broad overview of how attention works in our mind, but being aware of these processes alone can help engineers create better designs overall. When designing a product, engineers may often find themselves considering the many major components that they hope to effectively offer their user. For physical designs, regardless of complexity or size, an engineer aims for their users to effectively and efficiently complete some task with their product. As such, the engineer may consciously avoid leaving a user confused as to how the product is of use to them or how they might go about actually using it at all. Explicit consideration of human attention can help with this. Let's consider a pen, for example. It's fair to assume that most individuals may pick up a pen that they've never seen before, look at it once, and know that by clicking the top of the pen, it will allow them to write. In this case, the user's top-down processing will lead them to look at the pen once and expect the feature to do what it is intended to do without direction. Now let's consider that an engineer is designing some truly innovative version of a clicky pen. If the clicky feature will still be there but placed somewhere else in the product, specific consideration of human attention might lead an engineer to make a different choice about what the feature should look like in order to aid the user in intuitively using it. Digital designs require specific considerations as well. Thus, engineers may ask themselves how each major feature can be effectively seen and used by their end user. This is where knowledge of human attention directly comes to use. By being aware of how attention, especially top-down and bottom-up processing, occur in the human brain, engineers can make purposeful, intentional, and focused decisions in their design. These might call specific attention to the aspects that are important, while making other information feel more muted. In fact, the way that a design directly speaks to principles of human attention can determine whether the user interacts with it at all. The use of colors, shapes, size, and material can all feed into a user's decision to interact with a product. For example, research has shown that the placement of a simple logo on food packaging can lead to users making a quick decision on whether or not to pick it up. Findings like these are just one concrete example of how attention is relevant to engineers. Given this information, what might be done differently? First, engineers might intentionally consider the major aspects of their design and determine how these elements will be highlighted for the user. In physical designs, consider using a larger size for elements that are expected to be used more frequently. In addition, aspects that are expected to be there might not need to be fully highlighted in the design because the user's top-down processing will lead them to know where that feature should be. On the other hand, if the product is designed to be completely innovative and untraditional, that feature might be given a larger, brighter, or lit-up signal to the user. In this way, even innovative designs can still feel intuitive to the user. The same goes for digital designs. For those engineers who are responsible for the design of a brand new digital system, it is also useful to consider which aspects need to be highlighted. In the case of interfaces specifically, engineers can consider what users are already expecting in terms of the button layout, for example. Aspects such as a menu placement might call directly on top-down processing. In this case, the menu might be considered to be more muted as a whole. To summarize, by being aware of how human attention is drawn, engineers may be able to direct attention to a particular element of importance. Additionally, they may build upon what users are already expecting and focus on newer and more innovative features of their design.